Good morning, Thunder Bay. It's really nice to have you join us today here at STAO, which is this huge conference. So I'm not going to talk for long, but I'd like to thank Brennan for doing this for us, because this is a first for Thunder Bay, and of course Doug and Jason, who I've known for a long time. I heard Matt talking, but I didn't know how many people are there yet, but I'm finished now, so enjoy. I'm really thrilled that this is happening today. Take care.
Welcome everyone to Extended Inquiry and Problem-Based Learning in the Digital Age, which is a really fancy title. I tried to put as much edu jargon into it as I could to attract some interest. But in a nutshell, what we're going to be doing today is taking a look at the journey that Doug and I have been on for the last year and a bit, was specifically tied to our TLLP. However, we've had tons of experience with inquiry, which we'll talk about in a second, and some of the neat things we did getting students engaged in environmental science at the school. So if, just a heads up, I've created a bit.ly folder. I'll pop this up again at the end. I totally believe in sharing all my resources, so I'm dumping a lot of stuff into that, not just based around this project, but also based around all the inquiry I do. So in grade 11 chemistry, grade 12 chemistry, grade 9 and 10 academic applied science. I'll be putting a lot of folders into there of work that we've done, the planning, examples of student work and things like that, and then hopefully people can share and give some feedback. So if you want to toss any tweets my way, my handle's at jplot_tbay, especially later on if you're interested in getting making contact and getting some more resources or asking questions. And then at the end, I'll have our email addresses up so you guys can contact us that way. So first, I'll bring in my trusty sidekick here. Actually, he's my mentor, so I'll get Doug to come and just introduce himself and talk a little bit about himself there.
Actually, I'm not talking about myself. But I do want to tell you that he mentioned a journey, and that journey really started probably back in 1998 when I went to Churchill as a science chair. And that that principal at the time and myself had the opportunity to join the board as the hiring team. And my entire department retired out from under me in 2.5 years flat. So we're talking about 8 individuals and an opportunity to bring in the people that we wanted. And we were ideally placed because we were hiring for the entire board. So we were putting them on a short list, but then we were able to select from that list to populate the department. And the result has been a department that has basically stayed intact all of this time. And many of us are sort of getting ready to retire. And Jay came on 17 years ago and has always been at Churchill and has known nothing but inquiry science. So the project he's doing is embedded in the inquiry we got started way back then, but it's also big ideas, it's also case studies, it's also problem-based learning. And that's why, I think Jay is a tremendous resource to you in terms of what he can share. Over the years, we've been visited by 3 deans of science education. We have parts of 5 books and numerous journal articles on the science that goes on there. So just to give you a flavor, for what that looks like, on the left-hand side of the screen there, you can see an individual looking at a thermometer in the wintertime, but it looks like a fairly rustic setting. That's Fort William Historical Park in Thunder Bay, one of the top 10 destinations for tourism in Ontario. But we have a sharing relationship with their education department, and every winter in our first semester, so the semester ending this January, we take our grade 10 applied students there for their coming performance, and we have access to their fur collection. So the students are given the fur inventory, and they look through them and make observations and then decide on an inquiry they'd like to pursue. And usually that's around the insulating ability of a fur measured against animal blood. So we're giving them vials of colored water. And they wrap those vials in the furs, take them out in the snowbank and bury them, and then we track the cooling curve. We use modern digital probes for that, and really helps connect with an applied level student. They're looking at the systems kind of work that they've done in the climate change, the ecology they've done in grade 9 to put their knowledge together to produce these products. The template they're using, the scaffolding, is something we developed in a 3-week unit that every grade 9 student has to take no matter what level they're at, essential right through to IB, before they can start their regular 4-unit grade 9 course that you'd be familiar with. They have no exams and haven't had exams for 17 years, including the IB students. We threw them out. And instead we use oral defenses of the products they produce from an inquiry point of view. On the right-hand side, you might be wondering what do the students do in the second semester, right? The grade 10 applied classes. This is actually Fort William Historical Park again, but it's basically a Great Lakes St. Lawrence forest, elm and ash, outside the park walls, as it were. And we have students in there collecting, again, qualitative observations, but lots of data with their probes as well. And that's a morning activity, and in the afternoon, those same students go to a boreal forest plot and conduct similar observations. Their challenge this time is to tell the judges what the difference is between the two forests. And they have to use their evidence to back up their position. So on the way there, they meet the local university and college experts that help them along that road. There's lots of community sort of outreach. And we get 100% attendance generally, unless somebody's sick, which I don't know that a lot of applied grade 10 classes, can say they finish up, like that and with that kind of success.
So yeah, again, so what we're trying to do here is get students partaking in experiential learning. One of the things that, especially a grade 10 applied say at the end, is that they continue to learn something, even with the final activity, which is huge. How many students learn something at the end of an exam? Right? They don't. They're just sharing. They're trying to share as much as they know. But one of the beauties about doing something like this is that the learning cycle is still continuing, and the kids find that super beneficial.
Can you zero in on that?
Sure.
Character in the middle? So Susan, you might recognize this individual here. It's Mike Surrey, one of our department members. And the reason I've got him there is he's in a deep conversation with one of the students, and that's the thing about problem-based learning and inquiry, is you have a chance to be a facilitator. And you're never more powerful in your role as when you're having these kinds of conversations with students, as opposed to being the voice of authority in a dry room, telling students what to do every sort of moment of the day. Mike made a comment to me a few years ago that has always stuck in my head, and he made that during the oral defenses of some of this work. And he said to me, when I assess these summative performances, it feels like we're all still learning, and that's not the sense you get in a traditional exam. In fact, most students never see their final exam. And in the current age, of descriptive feedback, that really doesn't make a whole lot of sense to us, which is why that comment is so appropriate, because it builds into grade 10. So in grade 10, we look for opportunities within the units to develop their inquiry skills, but we also ask our students to participate in our own school science fair. And so the questions we're getting there are not sort of the traditional been there, done that type of questions. We're getting a lot more sort of introspective thinking around something that interests or turn those students on. We don't require them to go on to the regional, but many do. We send upwards of 20 to 25 students to the regional, and in the past 15 years, I'd say we've had at least 15 students on Team Ontario going to the National Science Fair. So then the work builds again into grade 11 and then again into grade 12, where their final products that they're producing for their inquiry studies are pretty stunning, because we've been working at it for 4 solid years. all of us in the department through all levels. And I guess I'd say one more thing, and that's we originally started this because we became an IB school, but we quickly learned that what we were doing was way more, or as successful, I guess I'd say, with essential and applied level students as well. And you've seen, some of the evidence for that there on the screen. So yeah, we were sold a long time ago, and when we were looking for a project to attach the TLLP grant to, it was a no-brainer, to start looking at Jay's environmental science class and the project that he came up with.
Yeah, and so to just kind of tag on to that, so the students in grade 9 and 10 get this experiential learning. One of the things that has been, that we've worked with, and I know other science departments try and do, is bring a bit of the real world tech into the classroom. And so we applied for a TLLP grant, and through that we were able to get some goodies to bring in, not just to environmental science, but into our biology classes and our chemistry classes and physics as well. And these were some of the things that we were able to get through our grant and get a bunch of them, because the sort of the focus on this on going forward is developing inquiry skills, but the lab skills, so that students can pad their resume and say not only are they developing these skills of inquiry, which may be difficult for them to articulate when they go for a job interview, but one of the things that they could do is they can walk into a job interview and say, I've got experience working in the field using data probes. I can go and collect dissolved oxygen readings and write and collect that data and analyze it. I can test for nitrates and phosphates. And we'll go into a little bit more detail about that, but we wanted some tangibles, especially for students in the workplace pathway and at the going to college route, because we have such a strong environmental tech program at Confederation College with really high success rates for jobs. We try and steer as many of our students into that. Going forward, just to let you guys know, we're going to be discussing a lot of what we do, and some of this may be, like you may have questions. Please, at any point, stop us and ask away. We want to definitely engage in a back and forth, so you don't have to wait to the end to ask us any questions there. So what I'll do is just quickly go over a brief history of environmental science at Churchill High School. So we started as a center of excellence years ago in environmental studies. And what we did was we developed environmental science class, locally developed one, focusing on watershed management and resource management. It took a while to really figure out what environmental science could look like. We were lucky enough to partner with some local farmers and a local group called Roots to Harvest, which is doing amazing things. And we were able to start bringing students to a local farmer who does hydroponic tomatoes and cucumbers, and they're amazing. They're the best tomatoes I ever had in my life. In fact, I would not eat a tomato up until I went there, and now I eat them all the time. And it drove my parents nuts. I never ate tomatoes until I was like 24, 25 years old. But here what we see is some students doing an inquiry with wheatgrass. And this is where we really made a turning point. This is, at this point for environmental science, we really took a strong inquiry focus and a real world approach to it. And so we see some students here doing an inquiry. As classes, we actually grew and juiced and sold wheatgrass at a local farmers market. First year we did that, we made over $2,000, which allowed us to buy our own greenhouse. This lady here was actually a student teacher of mine, Erin Beagle. She was one of the best I ever had. Unfortunately, we weren't able to bring her into the school, but she's running the Roots to Harvest program. And so she's doing just amazing things. And now that program has students working in all 4 of the public schools in our city, running their greenhouses throughout the summer, and working with cafeterias where they get foods classes actually preparing food and bringing local produce into the schools and getting students talking about eating local food and making healthy choices. So definitely an excellent partner.
I just mentioned too that the only reason Erin's not working in our board is she got caught in the enrollment and hiring quandary that so many of us has faced, but she's really carved a niche for herself because she's also in charge of food security now for the Thunder Bay community. And most recently, she convinced the Lakehead board to build a large established greenhouse on board property at the board office, where the students are going to be coming to help grow food to be used in those cafeteria farm to cap pieces.
And so another big focus in line with this is getting students to become problem solvers. And so with our greenhouse, we needed a heating system. So actually we had a workplace student do research, design a heating system, and then our tech classes helped build the structure. The environmental science class, it was a UC class, helped put it together and run it. And for a couple years, we were growing tomatoes and cucumbers and lettuce and things like that all the way into November, all the way up in Northern Ontario. In fact, things were still growing into December and January, things like broccoli and hardier things, because we were able to keep the soil temperature warm enough. So really impressive. What you see here are two boys working on designing a hydroponic system for our classroom. So Habitat for Humanity gave us a sunglass rack where you could put glasses on, and we are converting it into a hydroponics table so that you can grow your tomato plants up, because when we grew them in the class before, they're getting to be 7-8 feet tall. So we need a structure, and we don't know what we're doing. They're fumbling through it, and it's going to be messy. But that's awesome, because that's where the real thinking really comes in. So they are responsible for it. They're planning it, and they're working with our tech classes, and maybe sometimes driving our tech teachers nuts, running down back and forth, trying to drive screw drills and things like that. But that's all part of what I think is a rich learning opportunities.
Jason, there's a question from Matt.
Okay.
He was wondering about logistics, busing, permission forms, and gear. Are they difficult to deal with for the inquiry exams that you do?
If you don't worry about it, no, they're not. I think so many people worry about those things. We just go and do them. And that being said, though, we have a tremendously supportive administration, which is a major hurdle, right? If you have administrators that don't like permission forms being or field trip forms being handed in sort of last minute because these opportunities come up and you have to jump on them, then yeah, that's an issue. But we definitely take safety seriously, so we do a lot of that pre-safety training ahead of time. But that I think you have to have the mindset not to lose sleep. You're going to have to deal with the red tape. It is a lot more difficult to bring and exhausting to bring students out into the field. But I think when you do that, you realize how much more rich you make the learning be. So I think it's a fair trade-off.
Just like to thank Matt for that question. I'm sure he's asking that for his audience back at the Lakehead, but also here. Matt was actually on that culminating performance to the forest as an observer. We used him as an extra set of eyes and hands in the field as well. Matt works with the Lakehead University Faculty of Education Science.
Mm-hmm. So one of the things, and I'll probably get Doug actually to talk a little bit about this, is we've got this river that comes right by our school. It's the Nebing River, and we're so lucky to have it. It's right across the field. Like you walk through the parking lot, go across a not very busy street, except for when school's out or starting, and we've got this wonderful river that it's used a lot by the community. So I'll just let Doug kind of talk a little, because this became the focus of our inquiry for my class this year.
I'll try and give you the real short abridged version. But when I first got to Churchill, as just a newly hired science teacher, there was a biology teacher there that was also the chair of the local conservation authority. And he sat us down as a science staff and just told us what the weir was for in that river. And years later, when I went back there as the chair, I kept thinking about that weir, and eventually I took a class down and we sat on the bank right here and had our class. And I asked them why it was there. And they probably came up with 16 to 17 reasons, as to why it might be in the river. And later, during the winter, if you got a winter class, we had pictures, we put them up and asked the same question, like, that weir's there, why is it there? And I remember driving over a bridge right here and looking at that weir when I was going to Churchill for the first time and thinking that. So that kind of a brainstorm is basically how we end up starting almost all our inquiries at the grade 9 or 10 level, even senior inquiries for that matter, is we give them the nature of the problem, that we'd like to challenge them to study some variable, for instance, that affects homeostasis. And at the grade 12 level, they would just get into smaller groups and start brainstorming so much. But the start is in grade 9 on the side of that bank, talking about why is that weird there. And I could pick any number of those possibilities, but the one I sort of seize on is maybe it's there to put oxygen, into an urban stream, because you get a lot of organic decomposition from homeowners throwing stuff in there, right? And that robs the algae proliferates, robs the oxygen, ecosystem crashes. So I asked the students, well, how could you study that? And eventually, this is an oxygen probe, and I've got one in the backpack. So I pull it up. I go, yeah, it's right here. What should we do with it? And somebody eventually would say, we should put it in the water above the weir. I said, that's an awesome idea. Is that all we should do? And again, with that wait time, you'll usually get the answer, we should put it below the weir, right? And then, okay, so I'll put it right here, and I drop it into the water right at the bank where my feet are. They go, no, you can't put it there. Where are we putting it? In the middle of the stream. How deep? How far upstream and downstream of the weir? Right? The questions are rich, and they're doing inquiry without even knowing it in the first 2 weeks of their experience at Churchill. So, this is our Envirothon team. We're working with a soil scientist, and I haven't met one yet that isn't eccentric. And this is all beard right here. You put a red outfit on them, you got a sprinkle. But they're digging a soil pit to do a soil analysis of the soils next to the bank, and what is that going to tell them? So we use the river a lot, and Jason looked down there and thought that could be a next step for us.
Yeah, especially one of the things about our school, we didn't mention it before, we do have a fairly substantial Indigenous population, and a lot of them are coming from Northern First Nations communities. Years ago, I was working with a student, and we were doing some of this, but not to the level that today. And when it was hard to make a connection, and finally he started telling me about his community and that they had a landfill site right by the creek where they pulled their water from. And I said, well, what's it like there? And he goes, well, people just throw their trash all over. I go, well, what do you think about that? And he used a little bit of colorful language because he's like, all that stuff goes into the river, and then we pull out our drinking water, and we've had to boil water for years. And so water is super crucial. Most of the Indigenous students that I talk to can explain to me the water cycle. They may have a hard time with some of the chemistry that we cover, but man, they know the importance of water. So that's always been the back end. Water, it should be, those of us that live in an urban environment should care a lot more about water. But these students are coming from the north. Most of these kids have water advisories constantly. Some of them have only been able to boil water for consumption their entire life. And so I see something like this as empowerment, because what I'm hoping we go later on is we get these students coming back when they go home with water samples that we can be testing. And I want to train an army of lab techs and have them go through our college and university programs so that they can go back up north and make our urban students who are Indigenous and non-Indigenous aware of these issues, so that they can say, these water issues are a fundamental human right issue. We need to make sure Canada, one of the most prosperous countries in the world, should have clean drinking water for everyone. And so that conversation I had with that student was about 8 years ago, and that's always been in the back of my mind. It kind of drives where we're going, where I've been going this year. So we're going to jump into where we went this year, but what I want to do is take you guys through the planning and how it was carried out, because so many times we show you guys, hey, we did this really neat stuff, but how would you as a teacher actually know how to get something like this up and off the ground? And so I want to be really open and transparent about how I planned this, how we carried it out, how I assessed things, and hopefully get some questions from you and some feedback. And then going forward, other people can try this out and say, hey, this worked, this didn't work. You need to think about this because I'm, looking to improve my own practice. So these were the main skills and understandings that we wanted to develop. Scientific inquiry, critical thinking. We differentiate the inquiry skills. Critical thinking is a component of the inquiry skills, but when we isolate specific scientific inquiry skills, I'm talking a lot there about observations and developing hypotheses and the use of the data equipment, taking good observations. And then the critical thinking skills is analyzing data, both data you get from the field, but also research and looking at where those sources of research came from. Digital literacy skills, you're going to see in a second. We use a lot of different digital platforms. One platform we use a lot of is e-learning or D2L, some people might know it. We use Seesaw all the time in our classroom. And then we're using SparkView data probes and using the Spark elements, the little tablets that come with them. So the students are getting pretty extensive exposure to different digital platforms. Communication skills is huge. One of the first things when I was a teacher, when I became a teacher, I went to my dad and talked to him. My dad was a manager for all of Northwestern Ontario for Bell Canada. So he oversaw all their projects. I said, Dad, when kids leave my classroom and they go to work for you, what do you want them to be able to do? And he said, people cannot communicate their thinking. That's the most important thing. We can train them to do what they need to do, but they need to be able to explain verbally and in writing what they did, why they did, and why they did it. And so that's always been a cornerstone when I approach a class, is developing those communication skills. And then, of course, the fundamental or foundational knowledge of the curriculum. Notice I put this at the bottom. So when I talk about this, we're talking about specific expectations. The problem with environmental science, and no one here is from the ministry, right? There is far too much curriculum in there. So we are focusing on a fairly narrow component of the curriculum, and I'm okay saying that. I've got 17 years under my belt. I know what I'm doing. The inquiry, critical thinking, digital literacy, communication skills, I believe trump the curriculum. So we are going to go an inch wide by a mile deep into these things, and we will cover the relevant curriculum that allows us to really develop these skills. Students are still going to learn a lot, and we still cover pieces of every strand in the curriculum. But unfortunately, with environmental science, they made a curriculum this wide. And you do such a disservice if you try and hit every single piece of specific expectation. It's just too much. So I try and weave connections through all the strands and come up with thematic units. And that seems to work really well.
Spiraling.
Spiraling, apparently that's the new word for that now, yeah. Now, one of the things that's super important is how are students going to be able to demonstrate they've got these skills? And I've focused a lot of time the last 6 years on developing assessment, especially for applied level workplace level students, because I learned years ago that a written test assesses students' literacy skills way more than actually assesses their knowledge skills. And I think working with Doug and Mike, working with those culminating activities, doing those interviews at the end, interviewing students, you get way more data on and evidence of what they know and what they can do versus a pen and paper test. So one of the things is students need to know exactly how they're being assessed. So they need to be trained how to showcase their skills. That's data probe skills, that's communicating, that's the knowledge that they've gotten. A big thing that we'll talk about in a sec is how we will develop a system for students to show that they've got these lab testing skills, and then how we can show how the assessment's taking place in a way that builds pride. One thing that we don't talk, that I've actually never heard anyone talk a lot, is developing pride with our students. And that's, through all the work that I've done, that's the one thing that can bring students into a class, get them to turn the corners, to make them feel proud about the skills that they have. And so I'll explain in a second how we've engineered a system to develop that. And then, of course, the communication skills. Various communication skills. So skills one-on-one, talking to each other. Skills where students make video blogs. Students will be blogging on like things like Weebly and stuff like that. And students will learn to develop lab report writing skills.
Hang on one second.
Yep.
So I just tag on to that, you know, in your ministry document on expectations, the first unit are inquiry skills and understandings. The last one is knowledge and understanding. And still, we're teaching the way we were taught, what we remember, you know, from that classroom. And that's what I'm hoping is coming across in the work that Jay is explaining, is that there's a way, you know, to get at your knowledge and understanding through the interview process, but also through demonstrating their understanding in different ways. And those are legitimate, as long as you're documenting that approach, those are legitimate ways to be able to arrive at a midterm or final mark. So for me and for a lot of the department, knowledge and understanding can be done with unit tests. And that's enough. You're chunking a reasonable amount of material for students to be able to give you those kinds of expectations back, right? Knowing that unless you're taking a specialized area at a post-secondary institution, you know, when are you going to see a lot of that material again? So that was the defense or the rationale for dropping the exam. Something else we learned is we are not the filter. High school teachers are not the filter in terms of the final destination for your students. It is not a badge of honor that they get to write your exam and have an 80 or whatever it is you decide they can have based on, you know, how you wrote the exam. So so knowledge and understanding takes 30%, but it's a component that is our test. It is not the final exam. So under inquiry communication and making connections in communication come all these other rich pieces, and we use those categories to fill that part of it.
So one of the things we need to look at is, or might be useful for you to see, is what assessment looks like in my classroom. Students do not see marks in my classes. I've dropped marks completely. They stop the learning. I don't find them effective. I've never felt good giving a mark. Why is this test out of 75 and not out of 25 or out of 300, right? We create these arbitrary values, and it's always bugged me. So what I do is I identify the things that students need to show me they can do. And I know this is pretty crazy, and I don't know too many other people doing this, but I've created a system actually working with some awesome math teachers this summer through writing an e-learning course, where we actually wrote the course, and all the assessment charts follow this simple premise, is that you've got a learning goal. These are the things you need to do to demonstrate that you've met that learning goal. You may have met it, you may have completely demonstrated that criteria, or you may have only partially demonstrated the criteria. And so that's where feedback becomes important for the students, so they can see where they need to go to make improvements. This works really well if you cycle your learning, so you give the students an opportunity to come back to this, or you give them a second chance to demonstrate their learning. And that's been the focus of learning at Churchill for years, is that we cycle the learning through, especially using thematic units or spiraling, allows you to come back to certain foundational knowledge pieces again and again, so that these important pieces, that these strands or threads, you can weave throughout a course, and the kids get another shot at demonstrating they can do it. Sometimes it starts with feedback in the classroom, and then you may do a test, and then after that test, you may have a post-test interview. But a system like this allows you to use any assessment method that you want, as long as it's rigorous, and then that's all your data is right there. And for my workplace students, I use something like this, so that it's real quick. Again, I've got the criteria here, and based on the activities we do in class and a lot of conversations, I can say, yeah, you've got, you don't need any help with this, you can do it correctly and consistently, or you're working towards it, you need a little bit of prompting. These things make sense to the kids, and they like the checklist idea, because then they can pull you over and say, Mr. Pilot, I can do this now. Bring that sheet over, I'm gonna show you I can do this. Awesome. And then you have your conversation, you pull out a whiteboard, you give them a chance to show it to you on the fly. If they can show it to you on the fly, great. For university college prep classes, I do this with grade 12s as well, grade 12 university chem, say they do bad on a test. What I do is I say, okay, show me tomorrow at lunch that you can do these questions on the fly. And they're like, oh, we did. Okay, good. 2 days later, you're going to come back one more time, because I don't know if this is reliable enough. So 2 days later, they come back in. I give them similar questions on the fly. If they can demonstrate over those 2 days, then those two conversations are great pieces of evidence. And maybe my test wasn't. And I'm okay to look at the results of a test, especially after what the class did, and say, no, I don't think this is valid. We need to do something else. So real quick, just to tell you how I structure the course, we use D2L as our sort of online binder. That's probably the easiest analogy for it. What I've done is I've created video resources using SparkView. They've got awesome, and I'm sure Vernier has similar videos if you get their toys. And what my students have to do is they have to watch the videos, and D2L, you can actually have it track if they watched the video or not, if they've gone to certain content or not. And I've also created quizzes with some of the videos. And these videos teach the students how to work the software, or how to connect, say, a flow rate monitor and use it properly in the field, things like that. What I've done, and this is coming back to this idea about creating and instilling pride in your students. Years ago, I had a student who struggled in my grade 10 applied science class, but over the summer, he went and worked for a local forestry company, part of Forest Rangers program. And part of that program was kids were taught how to use chainsaws, and they were given the initial training course into firefighting, and they got training on all these different things that would be important for someone working in the field of forestry. And the kids got little cards. And this kid took out his wallet and showed me all the cards that he got. And he was so proud. That year, he did so much better in all of his classes because he felt like he had some worth, that he had employable skills. Because he said, when I go in, they told me when I go into an interview, I take these cards out and I put them on the desk. It doesn't matter who I'm going for, if I'm going to work at Safeway or whatever, it doesn't matter. I'm going to show that boss that I can do these things. And so that's always been the back of my head. So what D2L allows you to do is create awards and certificates. So an award would be something like watching a video, or getting 5 out of 5 on a quiz, or 4 out of 5, or whatever you want to make that be. And so we've created some awards for the students to do the prep work before they go in the field. And then I can sign off on other awards where they demonstrate proficiency in the field, either at the riverside using the digital probes, or in the classroom during the lab days. If they get enough awards and enough proficiency awards from me, they get a certificate at the end. So we will, certificate automatically gets printed out for them, and when they leave our class, that goes with them. And what we're looking to do is get little cards made up as well. So again, they can put that in their wallet and say, hey, I can do these things. Because we don't talk about pride enough. And I've never seen a monograph on it. I've never seen anything. And I'm not saying that I've read every single piece of literature in education, but that's one thing that people don't talk about, at least in my experience. And someone needs to do a master's thesis on that. How you can turn student achievement around by instilling pride in them, creating a system where where they can make improvements and feel good about that. And the best teachers do that. That's why the best teachers can get any group of kids to want to walk through a wall for them, because they create a system where kids feel good and they feel that they have worth. So we're trying to do that with this work. We use Seesaw a lot. How many, hands up, how many of you have heard of Seesaw before? A few, oh my Lord. Okay, so your homework is to go and check out Seesaw online. My wife uses it. She's a JKSK teacher. It has completely changed how she does assessment. In fact, the curriculum or the focus on assessment has changed so much for kindergarten that they almost have to use a platform like Seesaw in order to do the reporting of assessment properly. Seesaw is a web-based, app-based platform where students can take video and picture and upload files to a digital portfolio. The teacher can do that as well. Teachers can send out messages to the whole class. It's very easy to use. My wife uses it JKSK. I used it with grade 12 university prep classes in chemistry. It's a wonderful platform and it's free, which is really nice. I was going to jump into this here, but I'll show some videos later of students actually videotaping themselves, demonstrating proficiency with some of the tools. But we use Seesaw every day. And what's nice about it is you can use it for two things. Students can take video of themselves talking about solving a problem, demonstrating something, and that could be purely for them to use later to prep for a common activity, prep for a test, prep for a lab. So they can go back to their own video library and look at videos of their peers and use those videos to help them prepare for a rich assessment task or a test. And you can also use it for assessment. So when students post a video up, or they snap a picture of something and do a voiceover explaining what they did, annotating over that picture, explaining something, you as a teacher can give them feedback. You can assess their understanding at that point. So it's a wonderful thing, and that's your homework tonight, is just go and check it out. The YouTube videos explaining how to use it are so user-friendly that teachers who hate tech end up using it. Within a few weeks, it's almost fully integrated into their classroom. And we've had some schools in demographics in our city that there's absolutely no parental engagement at all. And this, the parents can get an app on their phone, and as students are demonstrating something in class and they post it, and the teacher accepts it, the parents get a note, and they could be out shopping, doing whatever, and they get a notification, they click on it, and there's their child reading. Or in our case, there's their child doing oxygen testing for biological or dissolved oxygen, or pH. And that's the pride thing that comes out. The parents now have something to talk to their kids about at the dinner table, and parents feel very proud about it. So I can't speak enough to this, because it is, in a few schools in our town, it has completely changed. A school that had no parents coming in for parent-teacher interviews, no parents coming in for activity nights. Now they have parents, grandparents, uncles and aunts. The whole school is full. They now have parents and grandparents coming in and using the computers in the school foyer that the school put out there to try and get people from the community to come in. It has completely changed some of these schools. And now we're trying to get parental involvement at the high school level. High school kids don't like it too much, but
13 minutes.
Okay. So in terms of getting the learning started, so what we start with in terms of how to get kids excited about doing this is we start looking at Hurricane Harvey and looking at the water pollution caused from that. Students, I posted some videos, we watched some videos in the class. Students had to go and read some articles, and they had to talk a little bit about what they found interesting and what they would want to learn a little bit more about. That got them thinking about water. Next, we started doing a case study with mercury pollution in water. The National Center for case studies. It's an amazing resource. Go pay the membership. It's the best thing, one of the best things you can do, because these case studies are written at all different levels. You can use them grade 9 all the way up to grade 12. What I really like about this case study,
I'll tell you at the end.
Oh, sorry. Okay. That's what it was called.
oh yeah, the National Center for Case Studies in Science.
It's out of Buffalo.
And what I'll do is I'll throw a couple of case studies in that shared folder, but you won't get the answer key because they ask that you don't ever give out the answer keys. So I will make you pay the fee. I'm not going to be.
It's only $30, so it's worth every penny.
What I like about this is you probably didn't see it quite so well, but at the beginning, it's like a story. Two people talking about having lunch, and one of them's pregnant. And then the other one goes, oh, you can't have the swordfish or the tuna, and why can't I? And then the conversation about mercury pollution. Throughout a lot of these case studies, students have to analyze data in different forms. So here's some data in the map. And here's some statistical data and graphical representations of data. So we're starting to develop students' critical thinking skills using these case studies. One other case study that we did is, I don't know if you guys have heard of White Dog First Nation or Grassy Narrows First Nation up by Kenora. There's been mercury poisoning there since the 1960s. So the Dryden pulp and paper mills put all this mercury into the water system. And Minamata disease has taken over and has affected those communities and pretty much decimated them. And just horrible things that they're going through. Our kids know about that. Most of our Indigenous kids come from the north, not necessarily the west, but they are aware of what's going on. And so we did a local case study with that. And it turned out that the Toronto Star did some investigative journalism and found out that the company lied and had actually buried mercury in the ground. They got a local former employee to show them where it was buried. They dug up the hole, dug the soil up, got tested, and the mercury levels were through the roof. And our Ontario government lied for years and stalled, dragged their feet on doing testing. They said that the mercury runoff in the water is natural or may be caused by logging, and that's not the case at all. There's mercury dumped into by the riverbanks from where the old mill was. And people were too afraid, I guess, for years to come up and say that they were part of that. So now we start with the river inquiry. So the kids are interested about water. They know that there's contamination and things like that. And we want to get them out there and just starting to play around with the equipment. One thing that I'll quickly show you right now, just a quick little video.
What did you notice on the water container?
Little dragonfly water bottle.
How do you know it's a dragonfly water?
They have stripes on their baby. That normally tells you what it is. It's got more
Can you do
than,
a close-up of it?
yeah.
Of the species found in the water?
Yeah, so the lady speaking to this student right here, this is Jade Lynn. She is definitely an interesting kid to have in your class. She is something, a lot of fun to have. My EA right there, Deb Chabot, is amazing. One of the hard parts about doing these field studies is you've got kids doing all these things, and a lot of times you need an extra set of hands. Deb is, she should be getting paid a teacher's salary because we sit down and plan out the course, and she is just on a whole nother level. And her ability to challenge students and ask them probing questions and draw out their thinking is something that I think a lot of teachers could actually learn from. She's worked with Doug and I in our science department for years. She loves working and going out in the field and mucking around with the kids. And she really allows me to make this program work. I wouldn't be at the level I am right now with most of these kids in the workplace program if it wasn't for her. So I really have to give her a lot. I wish we could have brought her down because she could talk for an hour about these kids and how she's able to engage with them. One of the things, the reason why I put this up here is you get little nuggets of understanding about what kids can do by taking these opportunities with them, which is really neat. And so getting them out in the field and just playing with the equipment before we even start the inquiry. This is not the official inquiry. This is just the kids learning how to use a water collector. Really important.
What did you notice?
So one of the things we had to do is we had to figure out what we were going to look for. So again, I isolated with the kids, what are the skills we are going to be working on in this inquiry that we're doing. So, you know, what are we trying to learn? How can you show that you've learned it? That's really important so that the kids know what they're doing. Next up, the students did a little bit of research. So they were put into groups. They had to research one water quality parameter. This is an example of one group that did it on nitrates and nitrites. This is something that we could test. We've got workplace kids working with academic kids here on this, and we have whiteboards all throughout the room, and each whiteboard had a different group working on research for the water quality parameter. They posted this up on Seesaw so that they could all go back and review it. And of course, I gave them feedback. If there are things missing, then I would definitely talk to them about that. And then they had to go in the field and start to isolate places of interest that they thought may be interesting. And they took pictures of that. And again, posted it on Seesaw so that, you know, the group said, this might be something interesting. We think that there might be fertilizer runoff coming from this. So the next crucial step is going from observation to inference to an official hypothesis. And so I'll throw a couple of these up here. This is what the kids did, is we took the pictures that they posted on Seesaw, I printed them out, they slapped them on a whiteboard, they describe what they observed. Then they discussed, they came up with an inference. Why do they think that that factor is there? And then from there, how do they think that factor may affect water quality parameter? And we put two, like this column right here is for one picture, this column right here is for another. And we get some groups that we get really thorough analyses. They're trying to compare multiple water quality parameters. They think this one will go up and this one will go down because they're pulling in all this research. And other ones are definitely a lot more simple. Oops. But we're still working on the same thing, right? You get a wide variety of skill sets, but they're all doing the same thing. And so it's easy, you know, in this case, they're talking about nitrates and phosphates. They still came up with a hypothesis. However, they're not wording it very well. They're not communicating it really well. So that's something that I identify I need to work with that team on. So once they have all that determined, we go out in the field. I'm just going to quickly show you.
18 minutes, so no one fall in. All right, gentlemen.
This is a contraption our tech group had to build so that we wouldn't lose kids in the river trying to take water samples.
A little bit before we pop the.
And these are two workplace level students doing this right now.
Release. Hit the use the white one, pull it tight, and try and pop the.
So the yellow cord drops the sampler in. The white cord pulls a trigger, releases a key so that the two balls at the end seal it up. Hopefully seal it up. As you can see in a sec, there's some water spilling out.
Oh, watch language.
I always show, I wanted to show this video because it's real kids doing real things. All right, so you can see, I'm sure you could see here, there's a lot of error in this process. It is not a clean process at all. It's messy, and there's a reason for that. When we're doing this inquiry, it's by far not perfect. You could not take this data and give it to the M&R and have them write a report. Instead, as you'll see in a second, I engineered that for a reason.
Keep taping it.
get dropped and I see that layer and comment on it. And it doesn't mean that they don't make mistakes, but now I've got a record of that. So again, and Seesaw, again, is so easy to use that it makes it really, really easy. So of course, individual groups put up their data, the class collected the data and put it together. Both sets of data posted on Seesaw so that everyone could see individually how they put the data up on the data table. I can assess this group's ability to collect data and post it. And then this was posted up so that the students could report on it. So real quick, we jump back into some research. This is a reporting phase, so the students have to write about, go back, do a little bit more research on all the different water quality parameters that they studied.
All right, we just jump in there too and take you back to their original hypothesis, you know, the thing they were looking for.
Which is right here, by the way.
Yes.
They had to rewrite it out again right here.
So they collected a whole gamut of observations regarding testing in the field. Their job next is to decide which test would be appropriate to look at their question, right? Because only certain answers to those tests or results would apply to their hypothesis.
Right. So right here, and it's hard to see from here, they had to report on 4 different hypotheses. And some of them may not have even been their own, and that's okay. Because some of the groups didn't do a good job of developing a hypothesis. It's one of their first real, attempts at this. So they were able to steal other groups. But like Doug said, if this hypothesis dealt with the weir and dissolved oxygen and pH, then I wanted to see that they only focused on those values and did a comparison of those values against the control there. What I was really happy about was that all the groups identified what was in the hypotheses and only described those parameters in this section, which is where they analyze it. What I wasn't happy about, and this was because of, I guess, how I ran it, I spent a lot of time with workplace students, saying to them, okay, does it talk about phosphate? Then you need to talk about the phosphate levels at the control, and now the phosphate levels, write what the phosphate levels were at the dam. Then give me another sentence saying whether it went up or down. Did it change or not? And then another sentence telling me why you think that was. So I really worked with them on it. I described to my UC students what to do, but I really only had 3 out of the 8 do it properly. So, and I noticed that the feedback I was giving was the same. It kept happening over and over again. So I need to now go back and have a conference with my UC group. And actually, I'm going to show them an example of a student from my workplace level, because her analysis was beautiful. It was, in fact, I told her based on how well she did on this, I think she needs to challenge and try and do the UC credit, because I think she's got, and she's starting to do homework now and things like that and look for opportunities. I want her to get the UC credit at the end.
We're there, Jay.
We're there, so I'll just wrap it up. So I'm actually going to give an exemplar to my UC students of work done by my workplace student. So I'm just going to quickly skip to the end here. So again, I'd love to go in and talk more about this, but in the Bitly folder, I'm going to actually put examples, pictures of student work up, as well as examples of how I assessed it. So this is, example of my assessment chart. What I would love from people to do is check it out and say what you liked, what you didn't like, what you think I wasn't thinking of that I should have, because we don't do that enough as teachers. And so if you're interested in this and you go into that, you'll see a little folder, examples of student work and assessment, and I want people to go in and check that out. And actually offer me some feedback on that. Try it out, see if this type of thing works, because that's the only way we get better. But what I like about this system is that if I give them, a not yet, I tell them why they didn't demonstrate that criteria yet. If I said, first time they didn't demonstrate it, but then later on in the report they did demonstrate an understanding, but it's still not complete. So there's still some things that they need to do in order to demonstrate that. I like this system, but maybe you guys can help me make it even better. And then maybe this can actually help inform what you do. So we're 4 minutes over here. is there any questions or things that you liked or didn't like? Because I'm more than happy to be challenged on my approach or things that you think I'm not thinking of.
How do you come up with a grade report?
Yeah, so what I do is, you know how rubrics have, like demonstrate a complete an excellent understanding? It's still really nebulous, right? What I do is I look at how many partials and how many completes. A level 4 means you've got a complete understanding in pretty much everything. You may need to just tweak one thing. A level 3 understanding would be you have mostly completes and a few partials. A level 2 is you've got a lot of partials, maybe one complete understanding, depending on what it is, and maybe one thing that's missing. A level 1 would be pretty much an equal balance of partial understandings and not yet. And that's how, and because all the evidence is there, and I just got a nice little ribbon that I put at the bottom with level 4, 3, 2, and 1, the kids can see why they've got that mark that they did at the end. Yep.
How long did this whole project take?
This project from now till last week. From September till last week. We wrapped it up, yeah. Thank you. Awesome, guys. Well, have a good day. Thanks very much for coming out, especially 9 on a Saturday morning.
We'll see you, Matt.
See you, Thunder Bay.
Take care.